Yes, hello Form 4s. Welcome back for our class, that is chemistry class. This one is the 8th lesson under rates of reactions. And today we want to do what is called measuring of rate of loss of gaseous product. The rate at which a gaseous product is lost during a reaction. Remember we said that you can measure the rate of a reaction based on the reactants, how the reactants are used up. You can measure the rate of a reaction based on how the quantity of the product formed at any given time. So you can base your rate on the rate of production of a gas or the rate of consumption of a given reactant. Now in our case, we are going to do an experiment, and this experiment is to measure the rate of reaction between marble chips. You know, marble chips have calcium carbonate and dilute hydrochloric acid. That's what we are going to do here. So what do we require? We require 250 centimeters cubic conical flask, this one here. We require 100 centimeters cubic of 2 molar hydrochloric acid. We require 2.5 grams of marble chips. We require a stopwatch. We require an electronic balance. This is our electronic balance. We require a cotton wool. Cotton wool. Cotton wool is here. We're going to use this. And then, now the procedure. So place 50 centimeters cubic of hydrochloric acid in a conical flask, and then weigh 2.5 grams of the marble chips. So we are going to measure 250, that is 50 centimeters cubic of hydrochloric acid. This one is 50. I don't need this. Keep it there. Then weigh 2.5 grams. Already I have 2.5 grams. Marble chips. And put it into the flask. So I will put my marble chips in this flask. That's what I have. Then the next thing, close the mouth of the flask with cotton wool, plug, and immediately place it over the balance. So close the mouth like this, and then we place it over the balance. I will place it over the balance. Then, like the one shown in this picture. So now then we are supposed to add the hydrochloric acid. So this is what we are going to use. Let me just explain that we will record the original mass. Immediately we transfer the acid here, we are going to record the original mass at 0 seconds. 0 seconds. So once we start the stopwatch and we place that thing there, we are going to record the original mass. Then after every 30 seconds, we'll be recording until the reaction is complete. So I'm going to turn it this way so that I can read. Now, so I will remove that and have my stopwatch with me ready. So once I add, it is 110.9. So I'm going to block it like that. So here we have 110.90. So after every 30 seconds, I will be recording the mass. After every 30 seconds, I will be recording the mass continuously. After every 30 seconds, I will be recording the mass continuously. Now it is 30 seconds. It is 110.62. 110.62. So after every 30 seconds, I record the mass. The mass is now 110.42. 110.42. For 1 minute. 10.42. Again, it is 110.27. 110.27. 110.27. It's 110.17. 17. One 10.10. 10. So finally it's 110.10. So that's what we have. That's what we have as our values. That is what we have as our values. Now, so from here, you will read and record the initial mass of the flask and its contents. Continue recording the mass after every 30 seconds to complete the table below. So we have our table. That is the table that I drew there, and we have completed it. So after that, we are supposed to work on the laws in mass. We're supposed to work on the laws in mass. So in working the laws in mass, so that we have a complete table, the laws in mass here, for the first one, the original is 110.9. The final is 110.9. So here, the laws in mass is 0. Because this is where we started. There is no change in mass. Then we are going to fill in this table. So that one brings us to the end of this first segment. Let us meet again in the second part.